Welcome back, ladies and gents. Mr. Callan here to help you with Chapter 5, again on Lesson 2 this time. We're talking negative exponents. At first, go ahead and pause your video, take a look at your answers from whatever the previous assignment number is. Come on back when you're ready. Goal today, take everything we've learned about simplifying expressions with positive exponents and change it to negative. Now, I want you to think about this. You all know m to the third means m times m times m, and m to the second, that would be an m times an m. M to the first, that's a single m. How about m to the 0? Well, we learned if we go ahead and divide by another m, cancel out, divide by another m, cancel out. What's m divided by m? That's 1. Okay, so we've got positive exponents. We have a 0 exponent. We now understand what it means. But what the heck does this mean? I mean, after all, how do you multiply m times itself negative times? Well, we're going to find out today that there is a way to use our mathematical reasoning to change this into its inverse, and it turns into something that makes sense. We're going to use that knowledge to go ahead and simplify expressions, which eventually help us simplify expressions that might need scientific notation. All right, go ahead, pause your video, whatever the date is, whatever the assignment number is. We have plenty of examples today. Pause, get ready, and when you're ready, come on back. All right, any non-zero number, the negative n power is the inverse of its nth power. So here's what I mean. You can take a to the negative nth power, change it to its inverse, 1 over a, and then the nonsense turns into something that makes sense. As long as a is not 0, right? Because you can't divide anything by 0. That's nonsense as well. So for example, 5 to the negative 4th gets changed to its inverse, and then the negative turns into a positive 4, and we get something that makes sense. Y to the negative 6th also gets changed to its inverse, and the negative 6 turns to a positive. Now, speaking of y, I mean, where the heck does that come from? There's no such thing as magic. As promised, we will use some mathematical reasoning to turn it into something that makes sense. Now, let's take, for example, 5 to the negative 4th. I think you would all agree negative 4 is the same as 1 minus 5. Now, when subtracting exponents, you could rewrite it as the division of 2 powers. Let me see if I can get my magic pen here. And it might pop up in a minute. I would like to point out, the last couple days, we actually went this direction. Now I'm asking you to do is to go that direction, okay? So 5 to the 1st, 5 to the 5th is the same as 5 to the 1 minus 5. Now, if I expanded all those 5s out, and I said any number divided by itself makes 1, look what's remaining in the numerator, a 1 and only a 1. Look what's remaining in the denominator, 5 multiplied by itself repeatedly. Now, at this point, you might ask, okay, Mr. Callan, but what if it's not 1 minus 5? What if it's 2 minus 6? What if it's 3 minus 7? Well, let's see what happens. We can rewrite this as the division of 2 powers, both of which have 5 as its base. The 3 comes first, so that goes in the numerator. The 7 goes second. That's in the denominator. If I were to expand this out, 5 to the 3rd power divided by 5 to the 7th. We ask ourselves, is this a combine or a cancel problem? Well, 5 divided by 5 is 1, and 5 divided by 5 is 1, and 5 divided by 5 is 1. And so we say, look what's happening in the numerator, 1 times 1 times 1. There's that 1 again. And look what happens here. 5 multiplied repeatedly, it's still 5 to the 4th. The truth is, you can make it anything. Shoot, you can make it 100, subtract 104. But after all, who wants to write all those 5s, right? The point is that all the 5s will cancel out, leaving us with 1 in the numerator. And 5 is going to be repeatedly multiplied 4 times in the denominator. So that's one example of why it works. If you want to, pause, rewind the video, and watch that again. But I have another reasoning behind where this comes from. So let's think about 5 to the 4th power. 5 times 5 is 25. 25 times another 5, 125, and go again, 625. 5 times 5 times 5, 125. 5 times 5, 25. 5 to the first power. Now remember, what does this mean? If you go ahead and you divide by 5, and we divide by 5 again, we get 25. 25 divided by 5 is 5. 5 divided by 5 is 1. Any number except for 0, any number to the 0 power is going to be 1. So what happens now, ladies and gents? Keep on going. 1 divided by 5. Well, I suppose we could write that as 1/5. Divided by 5 again. 1 divided by another 5 is 1. I almost could have said 1/25, but I'll just leave it in power form. And then, of course, this one divided by 5 again, and you get 1/5 to the third. So there's another reason behind it, and it all comes with following the pattern each time. Divide by another 5, so that cancels out at 5. Divide by another 5, so now let's cancel. Now divide by another 5 again. That explains where the 1 came from. And it shows you that nonsense can be turned into something that makes sense. That nonsense. How do you multiply 5 by itself? -2 times. But you can turn it into something that makes sense, and the pattern carries on. So there, Mr. Callan, I'm always trying to get into the why. Now let's go ahead. Pause if you need to, rewind, take it easy. This is a tough thing. When you're ready, come on back, and we will commence. All right, so first I see 6 to the -2nd. If I just slip a 1 under there, remember, we're going to change it to its inverse, and then the negative exponent becomes positive. Now, folks, it does just say rewrite using a positive exponent, so I do not need to actually evaluate here. I don't need to multiply it out. That's all we need to do. If you wish, you can go the long way for any of these problems. 1 take away 3, 6 to the first divided by 6 to the third, 6 divided by more 6's with 1 remaining, and look what happens. We end up with 1 in the numerator, 6 to the -2nd, 6 to the 2nd, in the denominator. How about x to the -5th? Once again, rewrite it and change the negative nonsense into something that is positive and makes sense. Pause if you wish, do the next couple on your own, come back when you're ready. 5 to the -6, we can rewrite it as 1/5, and now the nonsense turns into something that makes sense. T to the -4th will turn into 1/t, but now the negative nonsense turns into something that makes sense. So this is how you rewrite an expression with a negative exponent. All right, let's carry on. What if? What if you're the teacher and you know this is what your answer is, but you want to know how you would rewrite that in exponent form using a negative exponent? Well, as you can imagine, it is the d that is the repeated factor. And if we want a +5 down there, we would have to write a -5 as the exponent. So we could rewrite this going kind of backwards. If you were the teacher, you want the original problem, d to the -5th power. You might be tempted to here simply write 9 to the -1st, but forgive me for not being a little more specific. Go back to the directions. Write each exponent using a negative exponent other than -1. So the first thing I'm going to do, ladies and gents, is I'm going to change 9 into power form. I know that 9 is the same as 3 to the 2nd power. Okay, now I see that 3 is the repeated base, and if we want a +2 in the denominator, we can turn that into a -2. So imagine going backwards, 3 to the -2nd, turn it into something that makes sense. And then if you wanted to simplify, if you wanted to multiply out the 3's, it'd be 1/9. At this point, you might choose to pause the video, start up some of your homework, come on back and buckle up your seatbelts because the next few examples are going to get interesting. All right, simplify the expression x to the third times x to the -5th. I'm going to show you two methods, ladies and gents. The first method is old school. I look at x to the third and I say, well, that makes sense. I know what x to the third means. I'm not going to change it. But this is nonsense. So I'm going to multiply that by its reciprocal, and I'm going to change the -5 into something that makes sense. Okay, so if I rewrite this with the 1 in front times x multiplied repeatedly, and I write the denominator 1 times x multiplied by itself repeatedly 5 times, and now I ask myself, is this a combine or a cancel problem? Well, this is a cancel. Any number except for 0, any number divided by itself is 1. So in the numerator, look what happens. The only thing remaining is 1. In the denominator, what do I got? I don't need to write that 1 there. I can simply write 1 over x to the second power. Now, some of you might be thinking back and saying, hey, Mr. Callan, there was a time when you said when multiplying powers, you could simply take the two exponents and you can add them. And in this case, it is true. If we add 3 with -5, there are 0 pairs, and there are -2 left over. Oh, wait, that's nonsense. So imagine switching it to its reciprocal, and it's the same answer, isn't it? Now, I will be honest, in the homework assignment, I'm not sure it's terribly clear whether or not this is an okay answer. So I'll call x to the -2 a good answer, but not a great answer. It's not a great answer because it really doesn't make sense. How do you multiply x times itself negative times? So always try to simplify one step further, unless directions say otherwise, unless directions want a negative exponent, simplify one step further so that the exponent is positive. Two different methods. But if I can be challenging of some of you, the students with the strongest number sense skills can show their answer through both methods. So try to do that if you need that challenge. Okay, here is the doozy. First things first, x to the -5th, we are dividing it by x to the -2nd. I'm just going to tear this apart for a second. X to the -5th over 1, which is still x to the -5th. I'm going to rewrite x to the -2nd. I'm going to put a 1 up top. Okay, the first question I ask, does it make sense or is it nonsense? If I look at x to the -5th over 1, I know that is ridiculous. How do you multiply x times itself negative times? So I'm going to rewrite this as its inverse with x to the 5th down below. Now I'm going to go ahead and I'm going to try the next one, look at the next one. Is it working or not? Well, that also is nonsense. Whoa, wait a second. What the heck? Tell you what. Let me go old school, really old school. I'm going to rewrite x to the negative here. Let's go backwards. I've changed the way I want to teach this. So x to the -5th, silly, right? 1 over x to the 5th. X to the -2nd, also silly, right? 1 over x to the 2nd. Whoa, how do we have a fraction inside of a fraction? Well, let me rewrite this as 1 over x to the 5th divided by. I know I've asked you guys not to use that divided by symbol, but there's a reason I'm doing it. When we divide by a fraction, we actually leave the first one and we multiply it by its reciprocal. So I'm going to change this now. Whoo! I told you to buckle your seatbelt. So we have 1 times x in the numerator, 1 times x to the 5th power in the denominator. Is this a combine or a cancel? Again, it's a cancel. X divided by itself is 1. X divided by itself is 1. And let's look at our answer. We have 1 times 1 times 1 in the numerator. We have 1 times x times x times x in the denominator. Wow. All right, just relax. Let's try the other method. When taking two exponents with the same base and dividing them, we learned yesterday that you can simply subtract those two exponents. Now, it won't be a surprise to you folks. Mr. Callan does like to change his subtraction into add the opposite. So -5 increased by 2 will be a -3. Oh, look, that's a good answer, but it's not a great answer, right? So let's change it. And there's the same answer, isn't it? Again, some of you will like method 2. Some of you like method 1. I don't mind method 2, but the problem is I don't just want you to memorize something for a day or a week or even a month. If you don't remember this next year, if you're taking an algebra class next year, what's the point? On the other hand, if you know that this is nonsense, you turn it into something that makes sense. This is nonsense. You know in dividing a fraction that you change that to multiplying by its multiplicative inverse, by its reciprocal. And you know that any number divided by itself, it just seems to be a little more, I don't know what I'm trying to say. Rational is probably not the best word, but students with the strongest skills should attempt both ways. Now, you might need to rewind. I've only got a couple minutes left, these two examples, and I'm going to do method 2 both ways. Now, we know that when multiplying any products, you may change the order and get the same product. So what if I change the order to put the m's right next to each other, to put the coefficients right next to each other? Shoot, I could even change the association with the associative property. 8 times 2, 16. When multiplying two powers of the same base, I can simply add the exponents. So 16 m to the 4th power. If you don't believe it, think about m to the 6th power is good, m to the negative 2nd is not. Change that. Imagine all those m's up top, imagine a couple m's down below, imagine a couple m's canceling out, and that's where the m to the 4th comes from. Whew. How about the next example? Let's go ahead and reorder so that we can divide the coefficients and divide the variables. Of course, 8 divided by 2 is 4. Remember, when you're dividing two variables, two terms with the same base, you can simply subtract. And of course, Mr. Cowan will change his subtract to add the opposite, which leaves us with 4m to the 8th power. And again, if you didn't follow that, picture m to the 6th. That one's good. But then you're going to have to divide m to the 6th by 1 over m to the 2nd. Oy. Change that to its reciprocal, and look at there. That explains why all those m's actually increase, actually end up in the numerator up top. There's no reason really why you have to write over 1. After all, any number divided by 1 is itself. Folks, I warned you, it's going to be a rough one. We got one more piece, and I didn't put a picture of a virus. No, viruses are pretty small. But if you think viruses are small, think about an atom. So this says that a virus, 10 to the negative 7th of a meter. That's pretty tiny. But no matter how tiny you think a virus is, an atom is even smaller. An atom, in this case, the atom that they're measuring, it says average length of an atom, 10 to the negative 2nd. So very small. Now, apologies for the typo. The question here says how many times, and it should say how many times greater, is the average length of a virus compared to that of an atom. In other words, we need to divide virus by atom. Okay, let me rewrite that. Virus, 10 to the negative 7th. Atom, 10 to the negative 10th. Some of you realize that when dividing two powers with the same base, you can simply subtract the exponents. Mr. Cowan will change that to add the opposite. You end up with 10 to the 3rd times greater. Now, that's a good answer. I frankly would go ahead one more step. If you multiplied all those 10s out, you'd find that a virus is actually 1,000 times bigger than an average length of an atom. All right, folks, so you have the worksheet. You have a whole bunch of notes. You may either write all the worksheet into your notebook, or you may simply write your work straight onto the worksheet. And maybe I change my directions in future years. I don't know. Front side, back side is going to be 6 more problems that look like the very last example. Take care, do well. Let's grow, folks. See you.